Okay, power notes in front of you. This is solving compound inequalities. And they say part 1 because we're going to break up 3-6 into 2 ways. We're going to take notes a couple days in a row. One day about and, another day about or. I think it's easier to understand how these work that way if we treat them separately. So that's what we're going to do. So what is important about an and statement? Well, let's say I sent you to the store. You went down to the local 7-Eleven, and I said to you, bring me back some hot Cheetos and a Dr. Pepper. And you came back with only a Dr. Pepper and you forgot my hot Cheetos. Did you do what I asked you to do? No, that's correct. And so if I wanted you to get both things done, this and that, in order for it to be correct, both things have to be correct. So if you look at your power notes, okay, at the top, and it says, when the inequalities state this and that, they both must be true in order to graph it. And we're talking about where the graph crosses only. Okay, where the graph crosses only. So let's kind of take a look at what this and that would look like in terms of a graph. So let's say I had x is greater than or equal to -2 and x has to be less than 3. So let's take them individually. Okay, and so we put a 0 here, and let's deal with x is greater than or equal to -2. I'm going to do this in color so that it'll come up a little better for you guys. So greater than or equal to -2, it's going to be a solid circle. And greater than or equal to -2 is going to just take off and go on and go on and go on forever and ever and ever in that direction, correct? All right, x is less than 3. I'm going to put a 3 on here. It's an open circle at 3, right? And then it goes on and on and on and on the other direction. Now, we can see in both areas, like out here past the -2, there aren't both colors there, are there? And over here past the 3, there's only one color. And we're talking about and. So we need this and that. So where are they both going to have something in common? Well, they both are going to have a 2 in common. They both don't have a 3 in common, so we've got to leave the 3 open. Okay? Because the first one doesn't include the 3. And we can include everything in between. This is how we do an and statement when we graph an and. It's going to have both of those. And if you were going to think about doing it in a single variable, this is what it looks like. -2 is less than or equal to x, which is less than 3. And you can see parts of this, like you can see this x is less than 3. You see it right there. And you can actually see even the x is greater than -2. It's just backwards. It's over here. It's just backwards, so that they put things in the right direction. This is called more of a compound when things are all together. They always go from the lowest number to the highest number, so you always take your lowest number and put it on the left, your highest number on the right, just like the number line. See how these are? -2 and 3. There's -2 and 3. And you would put your circles on what's going on and what's happening. Okay? So you need a number that's greater than -2, but also smaller than 3. So you need a number that falls in between there, and those are the numbers that fall in between. So hopefully that makes a little bit of sense. So we're going to practice a few things. So let's graph number 1 here together. And so everybody write down -1 is less than x, which is less than or equal to 3. And let's add some numbers to our number line. We need a 0, we need a -1, and we need a 3. We know at -1, we need an open circle. At 3, we need a closed one. We've got numbers less than 3 and greater than -1, so we want just the things that are in between here. Okay? And I know your lines will be better than my lines, but you just want to make it a little darker so that it stands out on your number line. All right, so let's get a little bit into solving. As you can see, I have a solve. I told you to check visually and graph, and I'll tell you what I mean by checking visually. So let's take a look at this. Here we have -5 is less than or equal to 2x plus 3, which is less than 7. Now, there are 2 ways to do this. Let me move this over to here. We could, just like we did a moment ago, treat this like separate Inequalities. I can have one inequality here, and I can write that over here. I could say negative 5 is less than or equal to 2x plus 3. Why don't you guys hold off a second? Don't write, because I'm going to show you a shortcut. All right, and then here's the other inequality. 2x plus 3 is less than 7. And we can work them separately. So let me do that. I'm going to subtract 3 from both sides. That's going to give me 2x, doesn't change the sign, negative 5. And then I'm divide both sides by 2. There we go. And I get negative 5 halves is less than or equal to x. I do the same thing over here. On the second one, I'm subtracting 3. So you can tell I'm doing a lot of work, aren't I? Less than 4. And then I'm going to divide both sides by 2. Okay. And I think I did something wrong. Oh, I did. Oh, go back. I apologize, guys, over here. Oh, too bad I wasn't in the room with you guys to catch me. Somebody could have earned some candy. Negative 5 minus 3 is negative 8. Negative 8 divided by 2 is negative 4. At least I caught that. That's a good thing. Let me go back over to this one, and this is going to be x is less than 2. This is a lot of work, isn't it? Okay, so I'm going to show you guys a better way to do it. Okay, we're going to leave it alone just the way it is. So everybody has it written down like this, right? Okay, and I want you to think of doing things simultaneously. So it's almost like we're going to do 2 equations at once. I'm going to put, I'm just going to do that, but I don't think it's going to work really well, so we won't do that. What we want to do is we want to concentrate on what's going on in the middle, just like we would in an equation. So we got to get rid of the plus 3. So what we're going to do is not only we're going to subtract 3 from the middle, but we're going to subtract 3 from all the sides. Okay, subtract 3 from all the sides. We do that, and negative 5 and negative 3 is negative 8. Doesn't change the sign, does it? But it makes the 3 go away, leaving me just 2x less than 7 minus 3 is 4. So far, so good? So now, I want to divide everything by 2, because again, I'm trying to get that x alone, right? Divide by 2, divide by 2, divide by 2. And negative 8 divided by 2 is negative 4. Less than or equal to x, which is less than 4 divided by 2 is 2. And you can see in green, a lot less work than what's going on over there with the black and the blue. So what you want to try and do is don't take it apart, leave it as one. If you take it apart, when you put your answers, you have to have the word and in between here, this and that, or nobody knows what's going on. If you leave it as a compound, just like this, you can just solve it right away. Now, if they give it to you separately, you can combine it as long as this middle part is the same. You can combine it and just solve it really quick. That's going on. So it says on your notes, we're going to check visually. Okay? So let's first graph it, and then we'll check visually to see if we're good, if we got a good number. So let's put on here, on our number line, we need the negative 4. We need a 0. And we need a 2. We need an open circle at 2. And a closed circle at negative 4. We need numbers less than 2. We need numbers greater than negative 4. Because this is an and statement, we need everything in the middle there. Okay? Now, let's talk about checking visually. What number could I use that's between negative 4 and 2 to see if this really works? 0. Good. So let's plug 0 in there. So 2 times 0 is 0. 0 plus 3. So it's negative 5 less than or equal to 3, and is that less than 7? Sure it is. You can test numbers like 4, like pick the number 4 and see if it works. 4 times 2 is 8. 8 plus 3 is 11. If I put 11 in the middle there, is that going to make it true? No, it makes it false. It may be greater than negative 5, but 11 is not less than 7. So we can kind of check visually, pick numbers that are outside or inside, usually outside numbers, and see if it works. And if it doesn't work, then we know we're doing well. Okay, just keep an eye on that open circle and closed circle. Okay, let's do it again here in example 3. Where again, I want you to solve and graph and leave it as a compound, which is nice. It makes it go a little bit quicker. All right, so negative 2 is less than 3x plus 1, which is less than or equal to 4. So we're going to start out by getting rid of the constant. So we're going to subtract 1. It's just like solving a two-step, isn't it? Nothing's changed. Everything, we just pretty much do the same thing over and over, just gets bigger. Now subtracting 1 doesn't change the sign, so I'm going to leave it. Keep the 3x. Negative 2 and negative 1 is negative 3. A 4 and a negative 1 is 3. Then what we want to do is divide everything by 3. Okay, and dividing by 3 again does not change our signs, so we're going to leave our signs alone with the x. Negative 3 divided by 3 is still negative, and that's 1, and 3 divided by 3 is 1. So here we have our compound inequality, and we're going to graph it. So we're going to put a 0, a negative 1, and a 1. We will put an open circle at negative 1, a closed circle at positive 1. Less than 1 will go to the left, greater than negative 1 will go to the right, and then we're going to fill this in because we want this and that. Okay. Let's flip our paper over. And as you can see, we have 2 more examples to go. I'll try to be short and sweet. Okay, negative 3 is less than negative 1 minus 2x, which is less than 5. So again, we look in the middle. We need to get rid of the constant, so the opposite of negative 1 is a positive 1, or opposite of subtracting 1 is adding 1, so we're going to add 1 everywhere. And negative 3 and a positive 1 is negative 2. Bring that sign down, leave the negative 2x. Bring the sign down, 5 plus 1 is 6. We're going to divide everything by negative 2. So since we're dividing by a negative number, we're going to flip all the signs over. Flip, flip, and then put the x there. Sometimes doing the sign first when you know what's going to happen is easier. Negative divided by a negative is a positive, so we get a positive 1. And 6 divided by negative 2 is negative 3. So you kind of see things are backwards. This one's a little different, isn't it? We're used to the numbers going the other direction, starting from smallest to largest, and things going the same way. So let's see what's going to happen. So let's get a 0. We need a 1 and a negative 3. We need open circles at both. And let's take a look at this individually. X is less than 1, so we know that's going to go that direction. And x is greater than negative 3, so it's going to go this direction. Okay, and where they crisscross there, we've got everything we need right there. That's our answer. Okay, one last one. This one will be separated. I just want to talk about graphing this. So this one says x is less than negative 2 and x is greater than 4. X is less than negative 2 and x is greater than 4. So all we got to do is graph this one, right? So let's get a 0 on here, a negative 2, and 4. Well, we need open circles at both. So this is x is less than negative 2. Well, x is less than negative 2 is going to go away from negative 2. I mean, from the 0. We're going to go in that direction, the opposite direction, right? And it says x is greater than 4. So that's going in this direction. Now, in order to be an and, that means both things have to occur. Is there a number where both of these things are going to occur at the same time? No, there's not. So in this type, if you ever get to this point where you're solving and things are going in opposite directions, this is what we call a no solution problem. Okay? When we're dealing with ands, we're going to get possibilities of no solution. So we want to kind of keep an eye out for those. If they don't make any sense at the end like this, you're going to write no solution. And again, we talked about before, if you're writing no solution, you're going to put a 0 and a line through it. That's acceptable as well. Be careful with your homework assignments. Please make sure that you are being careful with how you are doing everything in your graphing. That's the end of the note.